What can I do? Which one can I do?
Are you going to go over questions right now? Or like after?
Pardon?
You can go over questions right now?
I'll go over a question right now.
65.
65. Tan theta minus 1, secant theta minus 1 equals 0. That one?
Yes, sir.
Okay. So we're asked to solve this equation, tangent of theta minus 1 times secant theta minus 1 equals 0, right? Solve this equation, and does it tell us where? Just on the interval 0 to 2 pi, right? It only wants from 0 to 2 pi. But I'll give you all the general solutions, then we'll get the answers between 0 and 2 pi. So the good news about this problem is it's already factored, right? You have two things that are multiplying to be 0, so you can set each one of these equal to 0. What?
I mean, now I see it.
You see it now?
Yeah.
Did you multiply it out? No? So you set tangent theta plus or minus 1 equals 0. Do you want me to keep going? Yes, I heard yes. Secant theta minus 1 equals 0. Set each factor equal to 0. Let's isolate tangent theta here. Tangent theta. Add 1 to both sides. Tangent theta is 1 here. Secant theta is 1. Now, tangent theta being 1 should be something you should be pretty familiar with at this point. You know, at what angles is the ratio of the y-coordinate divided by the x-coordinate equal to 1, right? That'll be here at pi over 4 and over directly across at 5 pi over 4. So our answers here, general answers, are that theta must be pi over 4 plus pi k. Because these are directly across from each other, this will cover all possible answers, right? Start at pi over 4, add a half rotation, half rotation. Good or no? Yes? Okay, that's that. And then over here, secant theta is 1. Well, remember secant's the reciprocal of cosine, right? So that means cosine of theta has to be the reciprocal of 1, which is 1. So where is cosine 1? Well, that's where on the unit circle is the x-coordinate equal to 1, right? That would happen here, right? That's it. That's the only place. So that, all general solutions for this would be theta must be this angle plus full rotations, right? And you can say this angle several ways. You could say 0, or you could say 2 pi. You can say 4 pi, 6 pi, whatever you want. So what do you want me to? 0 or 2 pi or?
0.
0? 0 plus full rotations, 2 pi k. And then, of course, you don't need the 0, so you can just write 2 pi k. All right, I'll do one more.
So you didn't need to do like 1 over cosine theta minus 1?
Minus 1? Where? Here?
Like in the very beginning.
You don't have to change that, no. You could just say, hey, when is secant 1? Do you agree with that? Do you agree I just moved 1 over? That's true? Now, here you could, if you wanted to, you could write 1 over cosine theta equals 1. Rewriting secant as 1 over cosine. And then you have a choice here. You can either look at 1 as 1 over 1, flip that, or you can do like a cross multiply. It's totally up to you how you do that. How would you do it?
I just did something completely different.
Completely different?
I try to get the same denominator. So I turn like tangent into sine.
Oh, you turn this into sine over cosine? Did you like try and multiply this all out? Yeah, so you don't have to because it's already factored, which makes the problem a lot easier because it's factored. Yes? 81. Tangent squared theta equals 3/2 secant theta. Can I erase? Tangent squared theta equals 3/2 secant theta. Okay, now on this problem it's not factored, right? We don't have everything on one side equal to 0, it's not factored. So a couple of different approaches to this. Did you try anything, or?
Well, tangent squared theta is equal to secant squared theta minus 1.
Okay, great. So you're using the Pythagorean identity. Now we have these Pythagorean identities that I gave y'all. Remember these? I don't recall if I used theta or x, but it doesn't matter. Right? That's our first Pythagorean identity. Do you all remember the other two? Or no? It's 1 plus tangent squared theta. It doesn't matter if you write that backwards, equals secant squared theta. On most formula sheets, it appears this way. And then there's another one. Did we talk about the third one? Do you have it written down? No? I'm going to review these today. I'm going to review these today before we start. But this right here, you're going to use this one, right? That's what you did? So you said, okay, 1 plus tangent squared of x equals secant squared x. Did you solve this for tangent squared? Is that what you did? So did you write like, let me write it. That up there, I'm gonna use this formula. Tangent squared, 1 plus tangent squared theta equals secant squared theta. So that's that formula with theta in there instead of x, right? And then you can rewrite the tangent squared theta as secant squared theta minus 1. So you can move that 1 to the other side. This, anywhere I see tangent squared theta, I can replace it with this. So that's what you did? Okay, that's fair. I'm okay with that. This becomes secant squared theta minus 1. Now you're doing something that I'm going to show a different way after this. And it's not necessarily a better way. But I hadn't really stressed this formula a lot to you as a class yet. So the fact that you got this is good. But you don't need that to do the problem. So, all right, we good with this? Questions here? Now this looks like a quadratic equation in secant, because I've got a secant squared, I've got a secant over here, I've got a number. So I'm going to bring everything to one side. Is that what you did? Okay, you should have secant squared theta. We bring this to this side, so we have minus 3/2 secant theta. And then we still have a minus 1 here, equals 0. So all I did there was subtract 3/2 secant theta on both sides. We clear? And that looks like a quadratic, right? So you made this substitution. U is equal to secant theta. And then rewrote it as u squared minus 3/2 u minus 1 equals 0. Yeah? Any questions there? All right. Now you have to see if you can factor that. So did you try factoring or did you do something else? What did you do?
I went to the math lab.
Yeah?
And
What did they tell you?
I didn't understand.
No?
They just told me like
So
AC.
AC method, something like that. Okay, so factoring quadratics, we all feel somewhat okay factoring quadratics if they're not fractions, right? Here we have fractions. So if this were me, which it is, I'm going to multiply by 2, and I'm going to clear all the fractions out of here. So I multiply that by 2, I get 2u squared. Multiply that by 2, the 2 on the bottom cancels, I get minus 3u. Multiply that by 2, get negative 2 equals 0. All right, that quadratic is probably a little bit easier for you to look at, yes? Now try and factor that. So if it were me factoring, I would go, let's see, I need 2u squared, so I'm going to put 2u here and u here. On the back, I need a negative 2, so I'm going to put 2 here, 1 here. And then I just got to get the signs right and hope that this works. So what is it?
2u plus 1.
Plus 1 and
U minus 2.
minus 2. And you can double check, it works. 2u squared minus 4u plus u, that's a minus 3u, and then 1 and negative 2 multiplies to be negative 2. Is that a little bit easier to look at that way? In the tutoring lab, they did it with fractions? They did AC method with fractions or no?
Well, he got your answer, the 2u squared minus 3.
Okay, so he got.
He was telling you about the AC method, and it was just
Yeah, so the thing is, you know, like in pre-cal, we hope that you walk in here with some factoring technique for quadratics, right? So if you had, like, most of the time we want to do what I just did, which is what we refer to as the guess and check method. You're kind of like just trying to make it happen. But if this doesn't work, you have to have something to fall back on. And so there's this thing called the AC method, right? So if you've never seen it or haven't worked with it in a long time, it can be confusing. Shall I continue? Yes? Okay, so we are going to go to solve those equations. So set that equal to 0, 2u plus 1 equals 0. Set the other one equal to 0, u minus 2 equals 0. You get two solutions. U is negative 1/2, and u is 2. All right, those are my two solutions. Now, what was u? Secant theta, right? So secant theta must be negative 1/2. And over here, secant theta must be 2. I'm going to use the reciprocal property of secant, that secant is 1 over cosine. And I'm going to rewrite this as cosine and then flip that. So cosine theta is this flipped, which is negative 2. And then this same thing, cosine theta is that flipped, which is 1/2. And we're pretty much here at this point because these are both just asking us to look at our unit circle and look at the x-coordinates and see when they're equal to those two values, right? So let's do the one that I know this one's going to work, okay? This one, we want to know where the x-coordinate is 1/2. That should be here and here, right? Or I'll get those later. Okay, here I want to know where the x-coordinate is what? Negative 2. Well, wait a minute. This is a unit circle, right? This only has a radius of 1, so we would have to be out here. That's not possible. So there's no solution to this. Remember, cosine is bounded between negative 1 and 1, right, when you graph it? So there's no way it's ever going to come out to be negative 2. So there's no solutions to this. So the only answers we have are these. All right, so what are those angles? Pi over 3 plus 2 pi k, right, to get back all the way around to it. And then the other one is 5 pi over 3, and then plus 2 pi k. That's what theta has to be. I hope that helped. Yeah? Okay. Now, would y'all like to see that problem without using the Pythagorean identity? Because really the only thing I had really talked to you about was the Pythagorean identity with the top one, right? This one up here. It's the one I really stressed. So when we were back at the beginning of this problem, tangent squared theta equals 3/2 secant theta. What I could do to start is try and rewrite everything in terms of sine and cosine. So tangent squared is the same as sine squared theta over cosine squared theta. Do y'all buy that? Yeah? Because tangent is sine over cosine, so when you square tangent, you're squaring sine and cosine. That must equal over here, how about if I write it this way? 3 over 2 cosine theta. So what I've done is I've rewritten secant theta as 1 over cosine. And then I just multiply it across. 3 times 1 and then 2 times cosine theta. So y'all still buy that? The next thing I'm going to do is clear the fractions. So I'm going to get rid of the fractions by multiplying both sides by the LCD, least common denominator. Can someone tell me what the least common denominator would be? You need a 2, and you need a cosine squared. Exactly. So this has cosine squared, that has cosine. So you need cosine squared. That has a 2, this doesn't have a 2. So I'm going to multiply both sides by 2 cosine squared theta. 2 cosine squared theta. Over here, the cosine squared thetas cancel, right? Over here, the 2's cancel, and one of the factors of cosine cancels. You understand that? So what's my equation? What's left here? 2 sine squared theta equals what? 3 cosine theta. Good.
Divide by 2.
The 2 was gone, right?
Yeah.
That's it. You okay with that?
Yeah.
Now, Sine squared and cosine. We need either all cosines or all sines. So because we have the sine squared, we can use that Pythagorean identity. And we can solve that for sine squared. Sine squared theta is what? In terms of cosine squared, what is it? 1 minus cosine squared. So I would rewrite this as, be real careful with this 2. 2, I'm replacing that with 1 minus cosine squared theta, and then equals 3 cosine theta. So just replace that with this. And then distribute the 2 through. 2 minus 2 cosine squared theta equals 3 cosine theta. And now we have a quadratic in cosine. So we can get everything to one side and then play the same game. I'm going to just take it all the way, all right? Because I'm almost there. I'm going to move everything to the right-hand side, because if I move this to the right, it'll be positive on the right-hand side. So I'm going to move that over there, move this over there. So I should get 2 cosine squared theta plus 3 cosine theta, then minus 2, and then equals 0. It doesn't matter which side the 0 is on. I can put the 0 over here, 0 equals that, or I can switch it. Quadratic in cosine. So if u is cosine theta, this becomes, that doesn't look like cosine. This becomes 2u squared plus 3u minus 2 equals 0. And then I can factor 2u, u, 2. This time it's going to be minus 1 here, plus 2 there. Solve that for u. U is a half. And here u is negative 2. But what's u? Cosine theta. So this is cosine theta is negative 2. And this one is cosine theta is a half. Same 2 solution. Same exact end result, right? Good question. All right. How about we do this? I still want to do a quiz today. I want it to be one question from your homework. But what I'm going to do is at the end of class, I'm going to give you, well, the last 10 minutes, I'm going to give you one question from your homework, and I'm going to give you one question from today's stuff. And I'm going to let you pick which one you want to do. Like you can either do the problem from today, or you can do the problem from last class homework, all right? So keep your homework handy, because you'll need it. I'm not going to let you use your homework, right? But if you have anything today that comes up, right, during the lecture here, if you have anything that comes up, please ask, all right? What were we doing last class? Do you remember? At the end, when we started the new section? Trig identities. And I told you that these identities are usually really difficult for students because you already know what you need to do. It's just a matter of having to do it and then use all these identities to get from one place to the other. So let's talk real quick about the fundamental things, the fundamental identities we need to be able to do well in this section. So identities we need to know. These are things that should be pretty much right at the forefront of our brains. We should just know that these are, I'm not going to say memorize, but we shouldn't have to go far to find these, all right? The first one are the reciprocal identities, which are the ones we've been using. Cosecant theta is 1 over sine theta, right? Secant theta, these should not look new to you. 1 over cosine theta. And then cotangent theta is cosine theta over sine theta, right? And of course we know that tangent theta was sine over cosine. Do you all feel comfortable with all those? Do you all feel pretty comfortable at this point with these? Yes? Okay, those called the reciprocal identities. And then we have the Pythagorean identities. Okay, that's those over there. And there are 3 of them. There's sine squared, I'll use theta, plus cosine squared theta equals 1. Then we have the other one, 1 plus tangent squared theta equals secant squared theta. And remember, with all of these identities, right, you could take this identity up here, you could solve it for sine squared. You could take this identity, solve it for cosine squared, right? Here you could solve for tangent squared, move that over. So these identities can be manipulated however you need them within a problem. Does anyone know what the third one is? No? Without looking it up, no? So here's I'm going to show you something, all right? Because this identity right here is probably the most important one, all right? Maybe even in this class, this is the most important one. If you can memorize that one, the next 2 you can get from this, all right? And here's how you do it. If I take sine squared theta, if I've got this memorized, what I can do to get this identity is divide everything here by sine squared. Hold on. Sorry, I'm doing the wrong identity. Divide this by cosine squared. Right, so divide everything by cosine squared. What would happen? Let's see, cosine squared theta plus, dividing. Divide it by cosine squared theta. Divide that by cosine squared theta. What is this? This one's 1, right? This one is tangent squared theta, right? This is tangent squared theta. Plus, this is 1. And then this, by definition, is secant squared theta. And do y'all see that that's the second Pythagorean identity? It's just these 2 are in reverse order, right? So to get from here to here, I just divided everything by cosine squared. The other one, I get by dividing everything by sine squared. So if I take sine squared theta plus cosine squared theta equals 1, and then divide everything by sine squared, this time, this turns into a 1, then plus cosine over sine squared would be cotangent, good, squared theta, equals 1 over sine is cosecant, but we're squaring it, so cosecant squared theta. That's your third Pythagorean identity. And again, you can move things around. If you needed to solve for cotangent squared, you could. All right, those are your 3 Pythagorean identities. The only other ones that you really need that could come up are the even and odd. Remember we talked about sine being even, sine being odd and cosine being even, this thing? That sine of negative theta is equal to negative sine theta. And then we had this one, cosine of negative theta equals cosine theta. So as we move through this section now and we start doing these identities, I'm going to be pulling from this and using this, okay, throughout today. If I could have somebody look back in their notes from last class, can someone tell me the last problem I did, the proving of an identity? I know I was doing some problems right from the homework.
Sine theta in parentheses.
Cotangent
Theta
plus tangent?
theta
Okay.
equals secant theta.
Yep. All right. So let's do this one. That was the last one I did? Yeah? I did do another one? Was there another one after that? Which one after that?
Oh,
I know there was another one in the videos, but you said in the video that
Well, let's just do this one. How about this? Sine u, we're going to use the variables they use here. Cosecant u, this will be a good warm-up because it's not that bad. minus cosine squared u equals sine squared u.
This one we did last.
Yeah, we did do this one, right? Well, this was the last one we did. Let's just warm up with this one, okay? Because this one's really straightforward. All right, so we want to prove this, right? We want to show that this is true. Whenever you're asked to show that an equation is true, you are never allowed to work with it like an equation. That's what I said last time, right? You have to start with one side and turn it into the other side. And we always start with the more complicated side. So I'm going to act like this doesn't even exist, and I'm going to start here and try and turn it into this. So this is the left-hand side of the equation. I'm going to write LHS for left-hand side. I'm going to start by writing that down. Sine u cosecant u minus cosine squared u. And I'm going to somehow manipulate this, massage it, move things around, rewrite it until it turns into the other side. So does anyone see something you can do? What is this? Cosecant is 1 over sine, right? So this is just sine u times 1 over sine u minus cosine squared u, right? And what's sine u times 1 over sine u? They cancel, right? You just get a 1. This doesn't become 0, right? That becomes a 1. So now I have 1 minus what? 1 minus cosine squared u. So that turns into 1 minus cosine squared u. And that is what? Sine squared u by the Pythagorean identity, right? By this thing right here, right? Just take this, solve for sine squared. So subtract cosine squared on both sides, and wouldn't that be, that's the definition, right? So this becomes sine squared u by the Pythagorean. And this is the right-hand side, and therefore we are done. Any questions? Sanat, do you have a question now? Come on.
No, I.
You're good? Okay. All right, we're going to do another one. These are just going to continue to be weird, and we're just going to have to beat these things down until we get to what we see. The thing is, we know the answer, right? Like, we know what we're trying to get to. It's just, can we get there? That's going to be the challenge. That one was very straightforward. So how about this one? Parentheses cosecant theta minus 1, and then here cosecant theta plus 1, and that equals cotangent squared theta. I should also mention that there might be multiple ways to get from the left-hand side to the right-hand side. Like, I might do it one way and I get there, and you might do it a different way and you get there. And as long as we both don't, like, you don't break rules, I don't break rules, we can have different paths, which sucks because that means there's not one way to do these. Every problem is uniquely different. So I'm open to doing anything you want me to do here as long as it's legal. What would you like?
Well, I was going to ask, can cotangent squared theta turn into cosecant? Like, cosecant squared theta?
We could start with this side, but if we did that, we would have to use this Pythagorean identity right here and solve it for cotangent squared theta, which means it would be cosecant squared theta minus 1, right? We could do that. We could rewrite this, so we could start with the right-hand side and start trying to turn it into the left-hand side. My recommendation is always start with the left, though. Start with the more complicated looking one. Start with the one that's messier and try and clean it up and make it this. Not to say we can't go from here to here, but it's always, not usually, easier to start here. So I'm going to start left-hand side. Yes. So you want me to actually FOIL this out. Like, you want me to multiply these together. Like here times here, here times here, here times here. Is there anything that's making you do that?
It's a difference in squares.
Yeah, you see it's going to become something over there because it's a difference of squares, right? These are exactly the same expressions, but one has a minus, one has a plus. So they are technically a difference of squares. So when we FOIL these together, it should be a nice compact answer. Cosecant theta times cosecant theta. That's the first multiplication. That's cosecant squared theta, right? Cosecant squared theta. Okay, then I do the second multiplication. Cosecant theta times 1 is cosecant theta. Then I do the inner multiplication, and that's going to be a negative cosecant theta. And those are going to cancel. And then I do negative 1 and positive 1, that gives me minus 1. These cancel. So I have now, that equals cosecant squared theta minus 1, right? But that is, look at this right here. Take this right here, subtract 1 from both sides. You would get cotangent squared theta equals cosecant squared theta minus 1, right? That's what would happen if I subtract 1 on both sides. So cosecant squared theta minus 1 is cotangent squared theta, right? And that's the right-hand side. All right, can I go to the next one? How about parenthesis 1 minus cosine squared theta, and then we have 1 plus cotangent squared theta, not cosine, and then that equals 1. Show that that's true. I already see like 3 different ways to do this. So I'm open to suggestions. I don't want the same person suggesting over and over, though. I would like to share the joy. So, shall we go around the room? We'll go around the room? Yeah, we'll start here at this table. Go ahead. What do you want me to do?
Change the first factor to sine squared theta.
Okay, so you see the Pythagorean identity here? Everyone see that can be changed to sine squared theta. All right, so I'm going to start at the left-hand side. I'm going to go ahead and write it down. 1 minus cosine squared theta, and then here 1 plus cotangent squared theta. And that's my left-hand side. And then you want me to rewrite this as sine squared theta. Everyone buy that? Is that all? You want me to just write this now? Do you want me to just write 1 plus cotangent squared theta here? No, you don't?
Would you be able to break it down into the cosine over sine?
Over here? You could, yes. You could do, but you would have to do 1 plus cosine over sine, right? You would? Do you want me to do that? I heard something else. What else did I hear?
Cosecant squared.
Yeah, so do y'all see that 1 plus cotangent